Let us quickly train our mind with more problems on composition of functions. Consider this function f from the set of all real numbers to real numbers defined as f of x is equal to x square, and g from r to z real numbers to integers defined as g of x is equal to modulus of x. Now, what is f composition g? F composition g of x is f of g of x. This is how composition is defined as. Now, what is g of x? It is modulus of x, and f of x is x square, and hence f of g of x happens to be f of modulus of x, and this is going to be my term now, and hence f of modulus of x will be modulus of x the whole square. Correct? Yes. Now, I'll end this problem by asking a nice question. Is f composition g same as g composition f? I'll leave it to you to try out. You may want to compute g composition f and try proving that both of them are not the same. The last question. Consider this function f from integers to integers defined as f of x is equal to x square plus 1, and the function g defined from again integers to integers as g of x is equal to 3x. Let us compute g composition f and f composition g, both of them. G composition f is given to be g composition f of x, which is g of f of x, which is equal to g of, what is f of x? It is x square plus 1. Now, if this is going to be my term in the domain of g, then what is g of this term? Let's say this is y. So what is g of y going to be? It is going to be 3y. So y is x square plus 1, and hence it is 3 into x square plus 1. What is f composition g? F composition g of x is equal to f of g of x. G of x is 3x. Now this is my y here. What is f of y? F of y is x square plus 1. Okay, let me say f of z because I have already used y. So f of z is z square plus 1. And what is my z here? It is 3x actually. I had substituted 3x as z. And hence f composition g of x is 3x the whole square plus 1. This is my answer. And hence, what did we observe? G composition f is 3 into x square plus 1, and f composition g is 3x the whole square plus 1.